Hello everyone. In this video we have another question related to an RC circuit. So I have a 2000 volt battery, a 3000 watt resistor and a 2 microfarad capacitor are connected in series with a switch. Calculate the current going through the resistor immediately after the switch is closed and after a long time. So we need to find the current at these certain two times. The time constant, and we've been asked to find the charge stored in the capacitor immediately after the switch is closed at first time constant and after long time from charging the capacitor. The time required to reach 80% of the maximum charge. Okay, as I mentioned while I'm talking, it is a charging process. We have a battery connected with a resistor and capacitor. So let's begin. For the first one, calculating the current going through the resistor when t equal 0. And we know from this process of charging capacitor, the time when equal 0, the current will be reaching the maximum. Now, generally speaking, we can calculate the current going through the resistor by using Ohm's law, but we don't know what's the resistor. Here we have 3000 watt, not ohm, but we can calculate by saying power equal I times V, and that will give me the current, which will be the maximum current going through the resistor immediately after closing the switch, and that's P over V, 3000 divided by 2000. That will give me 1.5 ampere. It's the current going through this resistor, okay, at t equal 0. Now, after really long time, let's say it's time infinity, after waiting a good time from charging the capacitor, we know that the current going through the resistor will be 0. Just as a reminder, this is the graph where I have the current in ampere over time in seconds. We know the current starts from the maximum, and as it goes, it will start decaying until it's vanish completely and it will be 0. Okay, so that's for the first part. Now, to find the time constant, well, we know the time constant required R times C, but we don't know what's the resistor. However, we know what's the current going through the resistor or going the circuit, and we know the voltage. So from here we can say I times R, that will be the voltage. From here the resistor will be the voltage divided over the current. So 2000 volt over 1.5, that will give me the calculation. It will give me a resistance. Sorry, let's just make space for ourselves here. That will give me 1.34, 10 to the power 3 ohm. That will be the resistance. Okay. Now we can calculate the time constant, RC. So it's 1.34 10 to the power 3 multiplied by, let's do this one. Doesn't look nice. That will be 1 bracket, and the capacitance, it's 2 10 to the power minus 6. Just doing the calculation, that will give me 2.67 10 to the power minus 3 seconds. That will be the time constant or the first time constant in this RC circuit. Okay, now we need to calculate how much is the charge stored in the capacitor during the charging process immediately after the switch is closed, which again time equals 0 at first time constant, and after a really long time, which is t equal infinity. Okay, so let's see. The way to do this is very simple and straightforward. What we're going to do here is, let's start with t equal 0. Well, we know at t equals 0 there will be no potential difference across the capacitor, and we know that means there will be no charge stored at the, inside the capacitor, which means Q initial will be 0. Great. Now at t equal tau, we can use the definition of the time constant. What does time constant mean? It means it is the time when I have 63.3% of the maximum charge stored in the capacitor. So I can say Q as t equal tau. It represents 0.633 of the maximum charge. Now, maximum charge can be calculated by saying C times V, and that will give me 0.633. The capacitance is 2 micro, and the voltage is 2000, so we can say 10 to the power 3, and from here we can see it is 2.5 10 to the power minus 3 coulomb. That will be the charge stored in the capacitor after the first time constant. Now to calculate at t equal infinity, which is waiting for a really long time to charge the capacitor, and we know from the definition that at that time the capacitor will be fully charged. So Q max will be C times the voltage, and you can see it from the top here. It's the 2 10 to the power minus 6 and 2 10 to the power 3, and that will give me 4 10 to the power minus 3 coulomb. That will be the maximum charge stored in the capacitor after waiting a long time to charge the capacitor. So as a reminder again, I can draw the graph for this scenario. Now this is t, or the time in seconds. That's the Q and coulomb, and we know we can reach the maximum Q max. Now at t equals 0 there will be no charge. At t infinity, usually or after a really long time, we can reach the maximum. So the graph will be growing exponentially like this. So here's t equals 0, here's t equal to infinity, which is the maximum, and somewhere around here will be the tau, where I have, so I'll just draw it here, we'll have the 63.3% of the maximum charge I can store in the capacitor. All right. Now, for the last part of the question, I'm sorry, let's go back a step. It's asking you finding the time required to reach 80% of the maximum charge. Okay, you can draw a line here. It's not going to take that much space. So it's Q as a function of time, Q max minus exponential t over tau. All right. Now we know he's asking me to reach 80%, so it is 0.8 of the maximum Q max minus t over tau. Q max with Q max will cancel each other. Just quick rearrange them to the formula. And that will be 1 minus 0.8. That will give me 0.2 exponential minus t over tau. I'll take the len, and that will give me minus t over tau ln 0.2, and we're looking for the time. Time will be minus tau ln 0.2, and doing the calculation, that will give me 4.29 10 to the power minus 3 seconds. That will be the time required to reach 80% of the maximum charge, or 80% will be charge stored in that capacitor with this setup. Okay, I hope you find this example really useful. After we used another scenario to find the current going through a resistor without knowing the resistor, then we apply that to find the resistor, then we find the time constant, and from there also we discussed the value of the current at specific time, when it's time 0, infinity, and the capacitor, the amount of charge stored in a capacitor in different 3 points, when t0, t time constant, and when the time was infinity, and finding how much time required to fill certain amount percentage of the maximum charge. I hope you find it useful, and I'll see you again in another video. Thank you.